Hello friends, welcome to my space. In today's section we shall be looking at the continuation of the linear inequality. Today we shall be looking at graphs of inequality. Now in graphs of inequality we consider two aspects, two vital aspects. We consider one variable and two variables. Each time we are drawing graphs of inequality, we consider these two variables, 1 and 2. Now, when we talk of one variable, we are simply saying that the value of x, or the unknown, is raised to power 1. For example, for one variable, I have 2x plus 3 is less than 5. This is a one variable linear inequality. Why? The highest power of x here is raised to power 1, and we have just x. So x is raised to power 1, so this is known as one variable linear inequality. In most cases, we will have something like 4x minus y is greater than or equal to minus 6. Now, you notice in this case, we have x and y, two variables involved, raised to power 1 each, but two variables involved. So many times, the problems you will encounter could be either of one or two variables, where you'll be solving for the values of x. If it is for two variables, you'll be solving for x and y concurrently. And then, after which, you have your graph. Simple procedure. So we shall be looking at some examples on how to solve one variable problem. So let's take some example. So for linear inequalities with one variable, let's look at one variable problem. So example, we have a tool to solve the linear inequality 1/3 into 2x minus 1 is less than 5. Now let's quickly run through this problem. So we have 1/3 into 2x minus 1 is less than 5. Now the 3 can come below here, so I can write this like this: 2x minus 1/3. So 1/3 simply brings down the 3 here, is less than 5. So when I cross multiply, so 3 moves over to this side, 3 times 5, I'll be having 2x minus 1 is less than 3 times 5, which makes 15. So we have 2x to be less than 15, minus 1 crosses over, it becomes a plus 1. So 2x is less than 16. So I divide both sides by 2. Automatically, it gives me x to be less than 8. I'm able to solve this problem. So x is less than 8. And even from here, I can still draw my number line. X less than 8. So we have x to be less than 8. Now, if we are to draw the number line for x less than 8, I decide to start my 0 from here. 0. In this case, I want to use 2, 4, 6, 8, 10. This way minus 2. So x less than 8. So it's going to be at this point here, less than. So I'll be using just a circle because it is just less than. Numbers less than 8 are to the right hand side, so I simply draw my arrow this way. So this is for x less than 8. Simple problem. Alright, question 2, using 2 dots for that. We are told to solve 6x minus 14 is greater than or equal to 13x. So let's look at this problem. We have a solution. 6x minus 14 is greater than or equal to 13x. Now it is always advisable to move your x to the left hand side. So on the left hand side I have 6x, on the right hand side I have 13x. So I move 13x to the left hand side, is going to be a negative 13x is greater than or equal to minus 14 on the left hand side moves to the right hand side and it becomes 14. So 6x minus 13x will give me minus 7x. And 7x is greater than or equal to 14. So I'm going to find x by dividing through by minus 7. Minus 7, so that this cancels this. So x will be less than or equal to minus 2. Now you will be wondering why the change of inequality suddenly. It was greater than or equal to before we got the answer. Now this is the secret. Whenever you are dividing with a negative number, please take note, whenever you are dividing with a negative number, it affects the inequality sign. So automatically the inequality sign changes. So from greater than or equal to becomes a less than or equal to. So this becomes our final result. Representing x is less than or equal to minus 2 on a number line, we are going to have it like this. This is 0, this is 1, 2, minus on this side minus 1, minus 2, minus 3. So our focal point is on minus 2. So I'm going to have my minus 2 here, less than or equal to, it means I'm going to be having a tick dot. So which direction are we moving? Which direction are we moving? Right or left? I'm going to be moving to the left hand side. What it means is that the values to the left hand side is less than or equal to minus 2. So my arrow goes this way. So this signifies x to be less than or equal to minus 2. You can see, remember I said in the previous video that the tick dot simply means the boundary is weak. That means the value minus 2 is also included. Alright, we take one more problem. That's example 3. We are told to solve the inequality 3 is less than or equal to 4x. So let's quickly look at this. The essence of all these problems, they are to make you recognize and memorize the sign, the way the sign changes. That is why I'm taking my time to do all this. So you have to be sensitive. So we have x plus 3 is less than or equal to 4x. Let's move the x to one side. So we have x minus 4x is less than or equal to, plus 3 moves over, it becomes a minus 3. So x minus 4x gives us a minus 3x is less than or equal to minus 3. Now watch, I'm dividing both sides by minus 3 on this side and minus 3 on this side. So this minus is what will affect this the sign. So this cancels this. At the end of the day, I'm going to have x to be greater than or equal to, this cancels out 1. You can see because of this minus, the inequality sign changes. So we have x to be greater than or equal to 1 rather. So my number line will take this shape. This is 0, 1, 2, 3. On this side minus 1, minus 2, minus 3. So greater than or equal to 1, this is 1. I'm going to make my dot tick. So numbers that are greater than 1 move to the right hand side. So I have my arrow this way. So this is for x greater than or equal to 1. This is how the inequality will look. So the problems keep going on and on. Once you understand the change of sign, you could solve any problem as far as one variable linear inequality is involved. I'm sure this is clear to us. So hopefully in our next video, we shall be looking at two variables, where we shall be plotting the graph of two two variable linear inequalities. So stay put. See you till then. Have a good time.